Alright guys, I am going to start from scratch on this review. I suggest taking thorough notes because, that's going to help. Let's start with, okay, so the first one, you're going to be given a set of points. So the set of, and I believe these are probably the same numbers that we did earlier in the week. I don't remember what day it was. I don't know. Friday? No, it wasn't Friday. Thursday maybe? Who knows? Thursday. Okay, so you're going to be given a set of points, and the question will state for you to find the domain and the range. Now remember, the domain is just the list of all the x values that are being used, and the range is the list of all the y values that are being used. And of course, we know that x values are always the first number in the point. So here, I'm just going to say it's the set of, and just make that list: -9, -4, 3, and +9. They do not have to be in numerical order. This one just happened to be. And if you notice on this particular one, all the y values happen to be the same number, 2, which is perfectly fine. You do not have to write the number 2 4 times. You can just say that the range is the set of 2. So that's number 1, stating the domain and range given a set of points. Number two, you're going to be asked to, given a graph, let's see if I can get it to go. Given a graph, you're going to be asked to state whether or not the relation is a function. Okay, so you're going to be given something like this, and these are probably not the same points from the other day. So let's see, this is 1, 2, 3, 4, 5, 1, 2. This is -5 and 2. That's where it's supposed to be. And then we have 1 and -2 and -3 and -5. Oops. I'm doing that all night. 1, 2, 3, 1, 2, 3, 4, 5. So right here, the pen seems to be a little off. 3 and -1, 2, 3, -1. And then, okay, so that looks like that's it. So it's just going to give you the set of points, and it's going to ask, is it a function or not? Now you can use the vertical line test. Of course, the vertical line test would be like, I don't know if it's going to let me do this or not. So we'll see. So you're just going to take a vertical line, and then it's not going to let me do it, is it? Nope, I can't just grab the line. That stinks. Just let me, nope. All right, anyway, so you would take that vertical line and you would move it from left to right, down the function or down the relation to see if it is a function. Basically, it's just a quick check to see if any of the x values are used more than one time. And of course they're not, right? Good, because we know that this was what, -1, 2, 3, 4. That was -5. This is -3 down here. This is -1. So all of those have different x values. And over here, obviously, it's a +3. So this one is a function. This one also happens to be 1 to 1. Remember, 1 to 1 means that none of the y values repeat either, right? Because here, like, this is 2. This is -2. This is -1. And down here, we've got negative, I think it was like 5 or something. So all the y values are different as well. So this one is a function because none of the x's repeat. And it is also 1 to 1 because none of the y values repeat also. If that makes sense. Yes. I'm trying to make sure my words make sense. So that's what I'm looking for. Is it a function? And if so, is it 1 to 1? Now, number 3 technically is the same question. It's just instead of giving you a picture, they give you a set of points. Let's see. So for this one, again, I believe these are probably the same number we did on Thursday. If not, that's fine too. It's a negative. And then -5, -5. Yes, I do believe these are the same numbers. They look familiar. Again, all you're looking for is, hey, do any of the x values happen to repeat each other? And of course, we can see here that -5 happens to occur twice. Again, we do not care what the y value is doing, so this one is not a function. And since it's not a function, it would also, like, we don't, 1-to-1 of not a function is not a thing. So if it's not a function, it's just not a function. Now, just as a side note, going back up to number 1, now number 1 is a function, even though it didn't ask it, I just want to say it. But it would not be 1-to-1 because the y values obviously repeat each other. So just as an example of that. So know what domain and range are. Know what a function means. Know what 1-to-1 means. That's 1, 2, and 3. Number 4, we actually get to do a little bit of math. Number 4, they're going to give you a function. So in this case, f of x equals, I do believe this is different from the other day, but it's fine, 2x plus 6. And then it'll say something to the effect of, hey, let's find the value of f at, and you'll be given a number. Okay, so this will be the problem that will be presented to you. And remember, that does not mean multiplication. That's its name. It's saying, hey, let's find the value of the function. And x happens to be 10 in this one. So all you're going to do is substitute 10 in, 2 times 10, and then plus 6. And then just work it out. 2 times 10, of course, is 20, plus 6, or 26. If you want to be super duper mathematically extra correct, we're going to write it as f of 10 equals 26. So that's pretty easy. Just plugging it in and multiplying and subtracting or adding or whatever. That's number 4. Number 5. Number 6. Let's see. 5, 6, 7. Oh, you know what? I went out of order. It's all good. You'll have it all written down. I totally skipped 2. It's cool. I'll come to those in a minute. I'll do those last. I can read, guys. Let's go on to number 5 on my paper. I printed a new one out this afternoon, and it rearranged the order, and I just realized that. It's fine. They're the same questions. They just put them in a different order. Okay, so 5, 6, 7, and 8 are all talking about the translations of the function. So like number 5, we'll say something. Say, hey, my parent function is f of x equals x. Let's move this graph 7 to the left. All right, so we just know that means our left and right movement is inside parentheses, and it's opposite of what we think it should be, right? So it would be something like f of x, well, let me write it in a different color so it's obvious, but that's the answer. So your answer would be f of x equals, and then to the left would be x plus 7, right? Left and right movement is opposite. And just to be super picky, I'm going to put that in parentheses. I know it's the same outside of parentheses, but I promise getting in that habit now, it's going to be helpful. Whereas number 6, similar problem, we start off different. It says, okay, well, instead of starting at x, let's start at f of x equals x plus 3. Okay, so this is my starter function. I want to take this function, I want to move it 5 right. So if I wanted to move it 5 right, what would I do? What would that look like? Okay, so these are the ones we kind of practiced on Desmos the other day. And we were comparing them. Now again, left and right movement is inside parentheses. So if I did that, it would be like f of x equals parentheses x minus 5. Again, left and right movement's opposite. And that plus 3 is just going to move down. So if I wanted to move it 5 right, that's what I would have to do to the function. Yes, that's 5 and 6. 7 and 8. 7. Yes, and 8. Now they didn't. I haven't printed out the final draft of this quiz yet. So I just want to make a comment on 5 and 6. It's totally a possibility that instead of left and right, it might ask you up and down. So I just kind of want to mention that while we're sitting here. Remember, up and down movement is outside of parentheses. So let's just pretend, like on number 5, it said, let's move it 7 up. Okay, so if it said, let's move it 7 up, it would be f of x equals x plus 7. Remember, up and down is like the sign you feel like it should be, and there are no parentheses. Whereas on number 6, like if it said, hey, let's move it 5 down, you would take the f of x equals x plus 3. Again, we started at a weird place, and then we would subtract 5 from that to make it move 5 down from wherever it's at. So again, adding and subtracting outside the parentheses moves it up and down. Again, signs make sense. Plus is up, minus is down. And then left and right movement is inside grouping symbols, and it's the opposite of what you think should happen. Okay. I'm going to say for the 37th time, not a fan of teaching translations with linear functions, but I'm not in charge of math like I should be. Number 7. Okay, so number 7 is going to give you another, like, hey, here's our starting point. So here's our starting point. F of x equals, that's an equal sign, negative 6x. So that's like our starting point. What we want to do is we want to stretch it. Vertically stretch by a factor of 7. Okay, so vertically stretching just means I'm going to multiply the function times 7, right? A vertical compression would be the same thing, but the number would be a number that's smaller than 1. Okay, so instead of 7, I might give you like a half. So if it's being vertically stretched, you're just going to multiply times 7. That's what it's asking you to do. Hey, what's the new function if I were to take this and make it steeper by a factor of 7? So your answer is just going to be f of x equals negative 42 times x, because 6 times 7. Oh, geez, I just realized what I did. Guys, it wasn't on purpose. Y'all are all giggling now. It's negative 42. Okay, so that's all you're going to be asked to do, is whatever your factor is, basically. That's what you're going to multiply by. That's what a dilation is. That's number 7. And so 8 and 9 are the two that I think were supposed to actually be like the original 5 and 6. And again, my paper printed it out in a weird order, so sorry about that. We are listening well. Oh, wait. My bad. Got to do number 8. Number 8. 8. Let's talk about number 8. F of x equals 3 times x minus 2 plus 4. Here we go. And it just says, hey, describe this graph. What's going on here? And I warned you guys that's going to happen. And because that's super duper important. Like if you can look at an equation and say, hey, this graph is doing this thing, then it's really easy to visualize. Okay, so first of all, we know it's being dilated. I'm multiplying the whole function times 3. 3 is a number that is bigger than 1, right? It's not the coefficient of x. That's a horizontal. It is in front of parentheses. So this is a vertical stretch by a factor I can spell, of 3. Which just means it's going to get steeper. Like the rise over run is going to change by a factor of 3. Very similar to number 7, right? We multiply times 7. We just happen to have a number in front on that one. Now the 2 and 4 are what's going to move it left, right, up, down. So this minus 2, right? It's inside parentheses. I know that's a horizontal shift. It's the opposite of what it's supposed to be. So this particular graph moves 2 to the right. And then because of the plus 4 that's outside of the parentheses, that's a vertical shift. It is not opposite. Plus goes up, so it's going to move 4 up. Okay, so that's what I'm looking for. All 3 of those things. I need to know that you know how it stretches or compresses, and how far it moves left, right, up, down. That was number 8. Okay. Now, the 2s that are repeats. Those are these. There's just the two questions about continuous and discrete functions, and I'm going to go back over those because it never hurts. So number 9, I think it's even a different scenario. So the store, no, this is the same one, right? A store sells games. I could spell sells games for $35 each. What they want me to do is write a function and then say if it's continuous or discrete. And then they want me to use cost C, and then they want me to use the number of games. They want me to use the variable n. So, I mean, we talked about in class how, like it's multiplication, right? You buy 1, it's $35. You buy 2, it's $70. You buy 3, it's $105, and so on. So we know it's basic multiplication. So writing the function in part should be easy, right? The cost is equal to 35n. Right, that's it. Then it's going to say, hey, is this continuous or discrete? So this particular one, of course, is discrete. Discrete in math just means that it's not a fluid line. I hate to use that word, but that's kind of how my brain does it, right? So like if I were to graph this, and you obviously don't have to graph it because I'm just sketching, right? 1, 2, 3, 4. Like I have 1 DVD, it's going to be $35. I have 2 DVDs, it's going to be $70. I have 3 DVDs, right? And so what's going to happen is that if I were to do this, it wouldn't make sense to connect these points, right? Or not DVDs. What am I saying? DVDs? Games. It wouldn't make sense to say, hey, how much does 1.75 games cost, right? I'm not going to need to know these values in between these spaces. That's a discrete function. I only need these exact values. A lot of times, not every time, but a lot of times discrete functions involve only whole numbers. In this case, it's obviously positive because we're talking about money and number of games, but like think about that. Whereas number 10, somebody was selling boiled peanuts. Right, and the boiled peanuts were for sale for $3.25 a pound. And again, they want us to write a function for that, again using cost C, and then number of pounds. Number of pounds. They want me to use P on this one, I believe. But it's the same concept, right? I know that it's price per pound, so the function's really easy. It's just going to be $3.25 times the number of pounds. And then we had the conversation in class how, okay, well, think about this one. Very rarely when you go to a market or something and you're like, hey, I need 2 pounds of that, 5 pounds of this, whatever. I mean, unless the person happens to be really good, it's usually like 2.03 pounds, 3.65 pounds, right? Like if you ask for 3.5 or something. So it's really difficult to get on the spot. So it's totally okay to have those in between numbers. It's more of a fluid output, right? So that the input can be different values that aren't necessarily whole numbers. It's okay to have rational numbers, I guess is what I'm trying to say here. So this would be a continuous function because the value that you're putting in, right, the pounds of peanuts, it's okay for them to be not whole numbers. It can be all of the numbers between 1 and 2, and all of the numbers between 2 and 3, and all the numbers between 3 and 4, and so on. Okay, so it's your quiz, and I'll see you guys on Tuesday.